So welcome to the 2022 paper, question B1. So we'll read down through the question and then we'll get stuck into part A. The image on the right shows the hooker sculpture in Air Square, Galway. The geometry of design is comprised of a series of planar surfaces. Figure B1, so this is our figure B1 here, shows the plan and elevation of our three intersecting planar surfaces. So the horizontal and vertical coordinates for points A, B, C, D, E and F are given, and partial coordinates for point G. So we've got A, B, C, D all the way down to F, and then partial coordinates, so we're missing two of the coordinates for G, and I've indicated here we want to cross up, down for our coordinates. The edges B, D and FG are parallel, which we can see here with those symbols. So that's obviously going to be important in finding G. Draw the given elevation plan and intersecting of the intersecting planes ABC, ABD and EFG. So let's start with that. So my highest coordinate here is 105, so I'll come down maybe 140 just to fit the elevation on the page. That's my XY line. And then our coordinates for A, we've got 160. That's A. 180 for B. 200 C. 225. 245. 190 for F. Let's indicate these for in front. D, E, F, and G is 260. G. So let's locate the elevation and plan. So some projection lines. Okay, so for A, first of all, I'm going up, so I'll do up 40 for A, down 70 from the XY. Up 40, down 70. I'll repeat that for all of our points. So B, up 80, down 35, skip F, so we're on to C, is on the XY line because it's 0. Do all my vertical measurements here. 105 for D. E is 0 again, so it's on the XY. And G, we do not have a vertical measurement for that. So let me just label A, B, C, it's down here, so I'll leave that as my C. E is also down there. D, and we don't know what G is, and F actually is 40. Okay, and my distance is then to my plan. Actually going to go so B is 35 down, C is 105 down, and 115 down, D 105, E 95, and G we do not know. So I'll label up my points again. B, A, F, 25. Okay, so now let's draw my planes. So I've got plane ABC, so A to B, down to C, which happens to be going right through F there. You can see that point F is actually on that line BC. Then we've got ABD, ABD unit point. There, D is down 10. No mistake. And then we have, final one is EFG, so we have E to F, E to F, and we don't have the position of G yet, but if we go back to our question, we said that BD and GF, BD, GF are parallel. Okay, so parallel lines are parallel in all views, so as evidenced there. So I'm going to draw a line parallel to BD in elevation. And that brings me out onto the position of G, so I can actually draw that in heavy now. And I'll do the same in plan, so parallel to BD from F. So I'll finish off drawing my planes. That's G. Empty up here. Forget about that. Alright, so part B of that question. They want us to determine the dihedral angle between the planes ABC and ABD. So AB is the shared line. Okay, so that is where we're going to want to find a point view of that. So we want to find the true length first, and then we want to find a point view. So I want to look out perpendicular, so my x1, y1 can be there. I'll get a straight line, or a true length, and then I want to look along that true length, so I can either look down that way or back that way and get an x2, y2, so x2, y2, and I'll get my auxiliary view there, giving us the dihedral angle. Okay, I could also project it this direction, doesn't really matter, once we're getting a true length of the line AB to begin with. So, true length of AB, my xy line, or x1, y1. I want this to be long enough to continue all the points. Project up all my points. I need to come a little bit further here now. Okay, so that's all my points projected out there along my x1, y1. Okay, so we're producing an auxiliary elevation over here, so projecting from plan, creating an elevation, so I take my heights from the elevation. So we'll start with AB first of all. So AB, so A, that's the height of A, all the way down. Here's A in my auxiliary. B, it's B, follow B down, across, yeah. C is actually going to be on the XY line. That's C there. It's resting on the XY here. And D, D down. There we have it. So I just need to extend D another little bit further. So D, A, B, C. So let's draw the planes A, B, C, A, B, C. ABG. Okay, so this line here, I'm actually going to highlight my line AB. I've found the true length of line AB in this position. Okay, so now when I look out along it, I can look back this way or out this way. I'm going to, just because I've got space up here on the top right, I'm going to do that. So, from my XY line, X2, Y2. So, X2, Y2. Projectile AB, D, and C. Now I'm going back to views. So this is my auxiliary elevation. Here's an auxiliary plan. So I'll go back to my plan from my X1, Y1 back to my plan view. I'm going to get my heights. So good way of checking is we want to get AB as a point view. So AB should be on top of each other here. Therefore, the distance from A to B, from the XY to A, XY to B should be the same distance, and it is. It's a good way of checking that you're taking your heights from the correct position. That's point AB, point D, D up, point C. Point C. Just putting on my page. Extend that on slightly. Okay, so almost a right angle here. We got, well, a very tight angle, very acute angle. So A, comma B, this is point C, and this is D. Okay, so this is the point view of AB. Alright, and determine that you draw an angle between them. Okay, so that doesn't require us to measure it, okay, but if you'd like to, you can measure the angle. If they say determine and indicate the angle, well then you'd have to actually measure the angle. But I'll just determine it, I'll just indicate it here. bullseye. For me that is 7 degrees. Okay, so 7 degrees there. Just indicate it. Alright, so on to part C. Draw the elevation and plan of a horizontal line on the surface EFG. So I want to draw a horizontal line on EFG, so a horizontal line will appear horizontal in an elevation, and project an auxiliary elevation which will show an edge view of the plane EFG. So they want us to then get an edge view of EFG, so we'll use that horizontal line to do that. Okay, so if we draw a horizontal line anywhere on this plane and we get a point view of that line, that will give us an edge view. So what I'll do is I'm going to take a horizontal line on F, because it'll just save us time. If I was to take a horizontal line here, then I'd have to locate that point on F and on G, but we have, or on GF and on EF or GE, right? But we have a point, so let's just use that. We're going to have horizontal line, bring it down onto GE, which will be there. That'll be that true length of that line, and we're going to look along that true length, getting an X1, Y1, and that will give us an edge view out here. So it'll be something kind of like that, an edge view, and that will be a point view of that line. Right, and indicate the angle of inclination of plane EFG to the horizontal plane. Well, our X1, Y1 is going to be the horizontal, is an edge view of the horizontal plane here, and this is an edge view of that plane, so that will in turn locate the angle of inclination between them. Let's do that. Horizontal line from F. Okay. And we'll locate that line down here in plan. So okay, so that line and that line are the same line. And this is a true length of that line, because it's horizontal and we're looking down vertically on top of it. So project out here a auxiliary. G, F, and E. Okay, we're projecting from plan, creating an auxiliary elevation, so my heights I will take from my elevation. E is on the XY line, so it'll be on the XY here. F and my point found here on GE are at that same height, so let's take that height, F, which you can see is the same height here. So that's good, once again a good way of indicating or checking, have you taken your heights from the same point, because we know we're trying to find a point view of that line, and there it is as a point. And G, right, so we have points E, F, and G, and that should give us a straight line view of that plane, and then indicate the angle. So here we have, in the question actually they ask us for the actual angle, indicate the angle. Okay, so we can measure, we might as well. So line up my bullseye, so that is 58 degrees. So 58 degrees. Alright, so that's part B completed. So part B, indicate Horizontal plane, yeah, done. Locate the position of point P on the plane EFG. So we're still looking for, we found a line on point G before, or on this plane before. Now we're looking for a point which is a distance of 40 from the horizontal plane. Okay, so in our elevation we can measure vertically 40 up because this is an edge view of the horizontal plane, so I can measure up 40 and it'll be somewhere at that level, and it's going to be 68 from the vertical plane. So in my elevation I'm looking straight at that vertical plane, but in my plan view that's the vertical plane, so I can measure out 68 here and draw a line, and it'll be somewhere along that line. So determine and indicate the true length of PS. So once we, first of all we have to find that point P that is on that plane. So to start off, measuring up 40. Okay, and as luck would have it, in the question there, F is actually 40 up, so P is going to be in line with F, which is going to be useful for us. And so it's going to be somewhere along that level, so it's somewhere along there. And we're going to measure down 68 from our XY line in our plan view, so 68. That's somewhere along there. Alright. Something not quite right there because it's coming off. Let me just double check my measurement here. Right, so 68. Is there. That is the correct position of it. So horizontally, right, and that's our horizontal line that we already found in the previous part. Okay, here we have where those two lines intersect. Okay, because that's representing that same line. So it's point P. And I can project vertically up, and that is point P. Okay, and it's a line we're looking for, so we're looking for the true length of that. So we found P there, we found P here. Now the distance from P to F, right, that is a horizontal distance. So when we're looking in plan, looking straight down on top of that horizontal line, okay, that is going to be a true length line. So we can measure that as a true length. We don't have to do any auxiliaries for it or anything. So I've got that at kind of 46, 47 millimeters. So I call it 40, it's kind of closer to the 47, so 47 millimeters there. Okay, determine and indicate, so let's measure that. We're putting an arrow just to indicate that is 47 millimeters. Okay, so that was a question B1 in 2022. Nice question, kind of comprehensive, kind of needing, requiring students to show a good understanding of concepts relating to intersecting planes there.